So today we are working on section 1-3, which is inequality interval and set notation notes. Our essential question that we're hopefully going to have answered today is, what are the three types of notation? The second essential question we're going to answer is, how do we use them to write the solution set of a graph? How do we use to write the solution set of, not solution wet, that's weird, solution set of a graph? So, the three types of notation are inequality, interval, and set notation. Inequality is probably what you are more familiar with. Inequality notation uses inequality signs. So if you have this symbol right here, that would be the less than sign. That means that if you're graphing on a number line, you would shade to the left, and you would use an open circle. An open circle, if you are familiar with this, an open circle means that instead of like a closed point, you've got a point that looks like a point, but it's just kind of hollow on the inside. That means there's no value on that point, but you're kind of using it as a placeholder. The next inequality that you might use is this one. That's the greater than sign. If you had a greater than sign, then you would be shading on a number line to the right. And again, there's no equal to, so you would again use an open circle. Just like that. So it actually looks like an O for open. Okay. The next inequality you might use is this one right here. So that is the less than or equal to sign. Just like the less than sign, you're going to shade to the left. But now because we have the or equal to portion of the inequality sign, you would end up using, trying to shift this over. You would end up using a closed circle. And a closed circle is exactly what it sounds like. It's a circle, but you've closed it in with shading. So, like that. That indicates that there is a point value at your value. So you do have a value there. And then finally, the last one that you might use is the greater than or equal to sign on a number line. If you have the greater than or equal to sign, that means just like the greater than sign, you're shading to the right. And in addition to that, because it has the or equal to, you're using a closed circle, which again means that you draw that circle and then you shade it in. So there is a value at that point. Wonderful. So that's inequality notation. An example might be that you have all x values that are less than 1. And here's my number line, and here is 1, and I might have an open circle because the less than sign uses an open circle, and I might be shading to the left, so just like this. Okay, so that's an example of inequality notation and how you would use it. Interval notation. Interval notation is always written from least to greatest. And if you know anything about domain and range is also least to greatest. So from the least to the greatest. If the solution is all real numbers, so all real numbers is that double bar R, then you want to use this. So all real numbers means from an arrow to an arrow. And if you've got arrows, that means it's going to infinity in both directions, in the negative direction and the positive direction. You'll always use parentheses around the infinity sign. And the way you write interval notation is, let's say you have a graph. Let's say that you have a number here, -2, and a number here, 5, and let's say we've got some endpoints here. So I'll try and make that as closed as I can. Make that closed. We're going to have some shading in the middle. Okay, so this is a solution set. We've got all the points that are between -2 and 5. So the way that you would write this is shown right here. So you would start out with either a parenthesis or a bracket, depending on if you have an open or a closed point on the left. So here I notice that I've got a closed point. So I would definitely use a bracket because I do have that closed circle right here. I would write my -2. I would put my comma, and then I would put my right bound, which is 5, and it also has a closed circle. So if it also has a closed circle, I'm going to use a bracket. So that's what it ends up looking like. So here, because my endpoints were both closed, that means that my endpoints are included in my solution set. But if I had open points, that would mean that my endpoints are not included in my solution set. So I'm kind of showing you if I had, let's see, if I had a situation where, if I had a situation where I had open circles at -2 and 5 and all the shading in between, I'd be kind of showing you where the boundaries are at -2 and 5, but I still would not include them because there's no value at -2 and no value at 5. It's kind of like the ghost of a point. So I would use those open circles. I would use the parentheses. So -2, 5. Like that. So closed circles use brackets. Open circles use parentheses. And finally, we come to the third notation, which is set notation. It looks like this. So you have that is a brace, so it's kind of like a squiggly parenthesis. That's a brace. You'll find those sort of above and to the left of the Enter key on your keyboard. So a brace, and then you'll have an X, because we're talking about all X values. You'll have a little bar right here. The way that that bar is pronounced, if you're saying it to someone, is such that. So the way that you say this is the set of all X's such that, and then you give some kind of inequality notation. So I'm going to erase this just because I need a little bit of space here to finish my notes on this part of the page. So I might say, and then here I would give an inequality notation. So I might say that I want to draw the set of all X's such that X is greater than -1. I'm just making something up here. This is not something you need to know. I just made up an example. So I want to write the set of all X values such that X is greater than -1. So if I was graphing that, I'd go ahead and I'd plot -1. I notice that it doesn't say greater than or equal to. And so if it doesn't say greater than or equal to, just like in the top set of our notes, if there's no or equal to, then that means that I have open circles. So here, here and here. Okay. So let's say that I want all the X values greater than -1, not equal to. So this is going to be an open circle. And if it's greater than, I'm going to shade to the where? To the right. So this is my solution set for what's given here. Now the way that I would write that in set notation is I would do my brace to begin. So practice a brace. You don't really need the parenthesis. It's just there in this example, but you can just write an X. So the set of all x's such that, and then I need to write the inequality notation for x is greater than -1. So I would write all the x values greater than -1. And I would end with the brace. So this is set notation. So far, I probably should have planned this better and done it in a color that's all consistent. But inequality notation, kind of like x is less than 1, that's an example. And then interval notation, so like -2, 5 with brackets around it or parentheses around it, depending on if you have open or closed points. And then set notation, the set of all x values such that x is greater than -1, that's an example of set notation. So I'm going to go down to my next part of the notes, and in my next part of the notes what I have are some examples. I've got lots of stuff going on with lots of stuff going on the graphs, and so I want to be able to see how to write all of the different notations. Sometimes if you just have one notation, it makes things really easy, especially the tie between inequality notation and set notation, because inequality notation is in set notation. Okay, so remember we've got this inequality that's inside set notation. Okay, so on number 1 is right here. If I start out with inequality notation, I notice that I have a boundary at 0 and a boundary at 3. So I'm going to put my least value on the left side, my greater value on the right side, and then x is going to go in the middle. Now, I have a closed point here, which means I'm going to have a or equal to sign. And I have an open point here, which means I won't have an or equal to sign on the other side. I should be using my less than signs. Anytime you have compound inequalities, which means that you have like 2 endpoints, you should be using the less than signs. And the reason that that works is because you're writing your values from least to greatest, so you will always have the lesser values, like 0, being less than or equal to the greater than values, the ones that are on the right side. So this is my inequality notation. I can easily make this set notation by putting a brace, an x, a such that bar, and then just copying my inequality notation in there. 0 less than or equal to x less than 3. And end with a brace. And finally, interval notation is probably the one that you've used the less, but it's probably going to end up being your favorite. You just write the boundaries from least to greatest. So a 0 and a 3 with a comma in between. If you have a closed point, that's a what? Bracket or parenthesis? If you have a closed point, that's a bracket. So you got a bracket around the 0. And then if you have an open point, you have a parenthesis. Okay, so now let's look at number 2. Number 2 for inequality notation, I only have one boundary. It's a 2, and it's on the left. So here's my 2. Here's my x. There's no boundary over here. That's infinity, so I don't have to write anything over here. I notice that I have the open point, so I don't have the or equal to line. And there's my less than sign. So for inequality notation, you really should only be using less than or equal to. I'm going to do the same thing for set notation as I did before. I'm going to write my brace. I'm going to write my x, my such that line, and then I'm going to insert my inequality notation and close with a brace. And then finally for interval notation, my left boundary is a 2. It's an open point, so that's a parenthesis. My right boundary doesn't exist. It goes to infinity, so you put an infinity sign. And for infinity, we have up in our notes, somewhere, there we go, that you will always use parentheses around infinity signs. So around your infinity sign, you're going to put parentheses. Okay, so I'm going to do 2 more, and then I'm going to see if you can do some. All right, so number 3. Number 3, there's no left boundary, just a right boundary at 3. Okay. By the way, my x is kind of going in the middle, and I don't have a boundary on the left, so that's why I don't put anything there. I have a less than sign like I always should, but should it be a less than or equal to? Well, I've got a closed point, so that should be less than or equal to. My set notation, I open with a brace. I have x's such that, and then my inequality notations. X is less than or equal to 3. Close the set. And then finally, for interval notation, my left side goes to negative infinity. I always use a parenthesis for infinity. My right side is bounded at 3. It's a closed point, so I use a bracket. It might help you to remember that the less than or equal to sign goes with closed points and brackets. The less than sign goes with open points and parentheses. So that might help you remember. And then the last one that I want to do with you until you try some on your own is number 4. So on number 4, my boundaries are -3 and 2. My x is in the middle. I have the less than sign. Should I have less than or equal to? Well, only if I have a closed point. Well, I have one here and I have one here. So I need both of these to be less than or equal to signs. My endpoint is included in the solution. My set notation, open my brace, x values such that -3 is less than or equal to all the x's, which is less than or equal to 2, and I close my brace. So I just copied my inequality notation. And finally, my interval notation, my left boundary is -3, my right boundary is 2. Oops. Both of them are closed points, which means that I use brackets on both sides. There we go. So I'm going to give you a moment to pause the video. I want you to try 5 and 6 and 8. So I will help you with 7 in a minute, but I want you to try right now numbers 5, 6, and 8. So pause your video and try them out. All right, folks. So right now I have kind of like the open shell ready to receive some end values. So for number 5, I've got a boundary on the left of -1 and no boundary on the right. So here's all of my -1s going in. And I need to be using the less than or equal to sign because of the closed point. I need the bracket because of the closed point. And then my far right boundary, which I only include on the interval notation because it's infinity, has a parenthesis around it. Number 6, I have no boundary on the left and a boundary of -1 on the right. I should be using the less than sign because it's an open point. I should be using the parenthesis because it's an open point. I should be copying inequality notation into the set notation braces. And then my left boundary really doesn't exist. It's -infinity, but I want to include that in interval notation and use a parenthesis. And finally, number 8. Number 8 is this one over here. I do have a boundary of -2 and 2. -2 and 2. -2 and 2. I should be using less than signs because the points are open. And I should be using parentheses because the points are open. Okay. So the last one that I really want to explain to you is number 7. Notice how number 7 has 2 areas shaded. That means there are going to be 2 answers for each one, and we're going to join them and make the union of the 2. So in the first one, if I just look at this part, That means that I have just a right boundary at -2. It's an open point, so I use the less than sign, and there's no boundary on the left. If I just look at this part, I have a left boundary at 1, no boundary on the right side, and I should be using less than or equal to because of the closed point. So I'm going to include that in my set notation. So the set of all x values such that I have x is less than -2 and 1 is less than or equal to x. But the way I join these is with a big U. The U stands for union. I'm going to do the same thing in interval notation. My first was from -infinity to -2, parentheses and parentheses for the open point, and then the union with 1, infinity, parentheses around the infinity, bracket around the closed endpoint. So I only have a couple more for you. I'd like for you to try these on your own. Pause the video and do as much as you can, and then I'm going to flip the video back on and I'm going to give you the answers to check your work. Okay? So go ahead and pause the video and try 9, 10, 11, and 12 on your own. Alright folks, so I want to go ahead and show you the answers. Sorry, I'm realizing that I forgot to write those things in. So I want to show you the answers so that you can check them. And then once you are able to check them, you can move on to the practice activity. I think there are only 9 questions on the practice activity. If you have questions, please let me know. Please email me. And I hope you all have a great day. Bye.